Hi, this is Mrs. Cribb. Today we're going to go through a practice problem on calculating empirical formulas for part 1. In part 2 we'll do one with molecular formulas. So what I have here is, this one just says find the empirical formula for the following with the following molecular composition. So this is your percent by mass. So we're going to do number 2 here. We have 40% carbon, 6.7% hydrogen, and 53.3% oxygen. So let me write that on here. We have carbon, it's 40% carbon, hydrogen and oxygen. I gotta go back and look at the compositions. 6.7 and 53.3. Okay, so 6.7 and 53.3. That's the percentages. Okay, the first step is to turn the percentages into masses, so that's easy. You could just write it down straight out, but I'm going to talk you through the steps. So 6.7 grams, 40 grams up here, and 53.3 grams. And that's because I'm assuming that if I have a percentage, a percent means the part of 100. Okay, because per 100. So if I had 100 grams, 40 grams of them, if it's 40% carbon, 40 grams would be from the carbon. If it's 6.7% hydrogen, 6.7 of the grams would be hydrogen. And if it's 53.3% oxygen, 53.3 of the grams would be oxygen. So that's the first step. The second step is divide each one of them by their particular molar masses. So we're going to divide by the molar mass. So the molar mass of carbon, if I look on the periodic chart, is 12.01 grams. The molar mass of hydrogen is 1.01 grams, and the molar mass of oxygen is 16. And remember, I'm going to use two decimal places in my calculation. So I divide by the molar mass, and this is going to just give me the number of moles for each one of these quantities. Pull up my calculator here. So I'm going to do 40 divided by 12.01, and I get, try that again. 40 divided by 12.01, I get 3.33, and this is going to be the number of moles. So I'm calculating the moles here, and now I'm going to divide 6.7 by 1.01, and I got 6.63. And oxygen, 53.3 divided by 16, I get 3.33. Alright, so each one of these are moles. Alright, the next step says to divide by the smallest, whichever one the smallest one is. So the smallest one, in this case, they're both 3.33 moles. So that we're going to divide by 3.33 all the way down. All right, obviously this one's 1, and this one's 1, and this one is 6.63 divided by 3.33. And that gives me 1.99. Okay, now this is a ratio. At this step we evaluate, can I round? So right here we're going to ask, can I round? And remember, I gave you a no rounding zone. So if the decimal portion is between 0.9 and 0.1, so if the decimal portion is less than 0.9 and did I get that right? Less than 0.9 or greater than 0.9. No, I did it the wrong way. I got my things written backwards. It has to be between these values. So alright, so if 0.9 is greater than the decimal portion and the decimal portion is greater than 0.1, then you don't round. This is the no rounding zone. No rounding zone. Okay, so if it's over here, bigger than 0.9, if the decimal portion, or over here, less than 0.1, then you do round. So we look at our decimal portion of this particular fraction or mole ratio, and it's 0.99, and that falls in this area. So yes, I'm allowed to round. So I round these to 1, 2, and 1. So now what is the empirical formula? Well, all these guys right here are the subscripts of my molecules, the atoms in my molecule. So this becomes C with a subscript of 1, H with a subscript of 2, and oxygen with a subscript of 1. Now remember though, in chemistry we don't have to write the subscripts if it's a 1, so it's just CH2O. Okay, so that would be the empirical formula. And we're going to just call that the EF, and because we're going to need to be able to calculate empirical formulas and molecular formulas for other calculation problems. So let's go back and look at my list of problems here. It was number 2, and the answers are down here, CH2O, correct. All right, great. Now, find the molecular formula for the following. Okay, these are not quite as complicated as the ones we're going to have in some of your homework, but we can go ahead and do a couple of these. Number 1, if the compound in question 7, I guess I got to figure out what question 7 is first. So let's do question 7. We have 7.19% phosphorus and 92.81% bromine. Oops, wrong thing. Go back to this. Okay, this is question number 7. We have phosphorus and bromine, and we're going to turn the percent composition into empirical formula. 7.19% phosphorus. And for bromine, it's 92.81% bromine. All right, step 1, turn them into grams. 7.19 grams. 892. Okay, 92.81 grams. All right, step 2, turn all the grams into molar masses. So I need to know the molar mass of phosphorus and bromine. So I'm going to go look over here. Oh, I didn't pull up my... Okay, I went ahead and pulled up the molar mass of phosphorus and bromine from the periodic chart. 30.97 for phosphorus, and bromine is 79.90. So multiply those out in order to figure out how many moles I have. And so 7.19. I'm going to turn on the calculator. 7.19 divided by 30.97. That gives me 0.2322. We'll do 4 significant figures. 0.2322. And for bromine, 92.81 divided by 79.9. And that gives me 1.162. All right, 1.162. That's the number of moles. Okay, now the next step is to divide by the smallest one. 0.2322. I'm going to divide both of those, and that's going to give me a ratio. The first one is obviously a 1 because that 0.2322 divided by itself is 1. And then I got 1.162 divided by 0.23. 0.162 divided by 0.2322. And I get 5. 0.00. I don't have to worry about rounding because that's definitely less than 0.1. So the empirical formula for this one is phosphorus with 1 and then bromine with 5. 5 atoms, that's the empirical formula. So now I can go back once I have that and look at this question. Number 1, if the compound in question 7 has a molar mass of 431 grams, what is the molecular formula? Okay, so we have a molar mass, which we're going to call MM, is 431 grams. They want to know what is the molecular formula. Now remember that the molecular formula is going to be basically taking the empirical formula and multiplying it by some factors so that the empirical formula, if it's exactly the same as the molecular formula, the multiplication factor would be 1. If it was twice, it would be multiplication factor of 2, and you'd multiply the subscripts each by that 2. And so I made up a formula for this. The N is going to be your multiplication factor, and it's equal to the molecular formula divided by the molecular mass divided by the empirical mass. So I really have to figure out, if I'm not told, what is the empirical mass of phosphorus bromide. This is phosphorus pentabromide. So we have to go through the whole molar mass thing for the empirical formula, that is. So phosphorus and bromine, 1 phosphorus atom, 5 bromines, and I know what their molar masses are because I looked them up before. So 30.97 and 79.90 for bromine. Okay, and multiply those and add them together to get the empirical mass. So I'll scoot this over for a minute. We should have 30.97 plus 5 times 79.9, which equals 430.47. Okay, 430.47. That's the empirical mass. All right, so to figure out this multiplication factor, I put in the molar mass that they gave me, 431 grams, divided by the empirical mass. And when I put that in the calculator, you could see that it's right at 1. 431 divided by 430.47 is approximately 1. Now what does that mean? That means that the molecular formula, MF, is equal to the empirical formula, and then all the subscripts are going to be multiplied by 1. So phosphorus 1, bromine Br 5 times 1. So the empirical formula and the molecular formula in this case are identical. So in this case I would label this one the molecular formula and this one the empirical formula. And on the test you're going to have to do all of these steps. Okay, this is the end of part 1. I'll do another one in part 2.